Graphing made simple. Our learning target is to graph linear equations using slope-intercept form. There are some bare necessities that we need. You need just 2 points, and when you have slope-intercept form, that always gives you 2 points. So, example number 1, it says that we want to graph y equals 2x plus 1. Step 1 tells you that you should plot the y-intercept. Remember that when we look at this equation, we were told that this is in y equals mx plus b form. The y-intercept here is always that b value. So you're always going to begin by doing the b value first. Well, plus 1. Plus 1 means I need to go up 1 on the y-axis. Remember, the y-axis is this up and down axis. Positive, again, means to go up. So I'm going to go up to positive 1 and put a big fat dot representing that point. The second thing we want to do, step 2, use the slope to find your next point. Well, remember that your slope is that m value, and that slope is verbally described as the idea rise over run. Our m value is currently the whole number 2. If I want this to represent rise over run, I need it to be in fractional form. Remember, I can turn any whole number into a fraction by putting it over an invisible 1. Rise, well, this number is a positive, so I'm going to go up 2. The 1 is positive, so I'm going to run 1 to the right. Remember, though, you're going from the existing y-intercept to do that. So from my existing y-intercept, again, my slope tells me I need to go up 1, 2, and to the right 1. And I put my second point. Last step, connect those points to form the line. So I simply need something to use as a straight edge. Make sure you put in some arrowheads showing it's a line going on forever, and you're done. Let's do example 2. We want to graph the equation y equals 2 over 3x minus 4. Now remember, according to our directions, we always plot the y-intercept first. The y-intercept in this case is negative 4. Ask yourself, what does the negative mean to do? That's right, the negative means we should go down. Now remember, I'm focusing on the y-axis, so from the origin I need to go down. 1, 2, 3, 4. Put a nice big fat dot that's easy to see. Now I'm going to focus my attention on my slope. Remember again that slope always represents the idea of rise over run. So what I want to do is look at my values. The 2 is positive. That tells me I'm going to go up. The 3 is also positive. That tells me I'm going to go to the right. But remember, those directions are from the existing y-intercept. So from the existing y-intercept, I want to go up 1, 2, and to the right 1, 2, 3. Now if I want to, I could actually do my slope again to have a more specific line. So I could go up 1, 2, and over to the right 1, 2, 3 again. Unfortunately, this graph is too small to do that example. Last step, take my straight edge, draw a nice straight line. Remember to include arrowheads to show that this is a line which continues on forever. Example number 3. This time we're going to graph the equation y equals negative 2x plus 3. Which value should we begin with? That's right, we should always start with the y-intercept. The y-intercept in this case is the positive 3. So on the y-axis, positive tells me I should go which direction? That's right, I want to go up. 1, 2, 3 from the origin, and put a big fat point. Now I want to focus my attention on my slope. My slope is negative 2. Well, remember, that needs to represent rise over run. It needs to be in fractional form. What can I do to any whole number to turn it into a fraction. That's right, I'm going to put it over 1. Now this time, my rise over run has a negative. This negative actually tells me that I want to go down. The positive one, though, still tells me I want to go to the right. Remember that if I were to apply the negative to both values, a negative divided by a negative is a positive, and then the negative sign wouldn't be there at all. Be very careful that you only use the negative sign on one of the two values. I prefer to say going down and to the right. You could also say that you are going up and to the left, but only negate one of the two numbers. So for this graph, from my existing y-intercept, I'm going to go down 1, 2, and to the right 1. Now this is an example where I could show you how to repeat the slope. I could go down 1, 2, and to the right again. And I could go down 1, 2, and to the right again. And I could go down 1, 2, and to the right again. And now I have lots of points so that I could make sure that I really line my straight edge up very accurately and draw a very good line representing this particular slope-intercept equation. Don't forget your arrowheads, showing that this is a line that goes on forever. Okay, let's look at example 4. The graph of the equation y equals negative 1/2 x minus 1. Which of these values should we begin with? That's right, we're going to begin with the y-intercept. The y-intercept is negative 1. Remember, that means where does my graph cross the y-axis? The negative tells me I need to go down 1. The second thing I look at is my slope. Now the negative is kind of ambiguous here. It's out to the side. For some reason that confuses students. Remember, slope is representing the idea of rise over run. When you have a negative, you need to do one of two things. You either need to go down and to the right, or you can choose to go up and to the left. Remember, you need to decide which of the two values you want to place the negative on for drawing your line. It doesn't matter unless you accidentally negate both. Remember that a negative divided by a negative would become a positive, and then the negative wouldn't be there at all. So again, when you have a negative, you either go down and to the right, or you go up and to the left. Based on where my camera is located, let's try going up and to the left. So this one tells me I could go up 1 and to the left 2. I could go up 1 and to the left 2. Notice this line does have a negative slope. The line appears to be going downward. Remember, we always read our lines from left to right. That's another good way to check to see if you drew the line with the correct type of slope. Finally, take your straight edge. Make sure that you draw a nice line going through all those points and across your graph, and include the arrowheads showing that it is a line going on forever. Finally, let's look at example 5. This time we're going to graph the equation y equals negative 2/5 x plus 4. Which of the two values should we begin with? That's right, we always want to start with the y-intercept, and this time our y-intercept is positive 4. Remember that y-intercept means where do I cross on the y-axis. Positive 4 tells me I want to go up 4. There's my big fat dot, easily found. What do we want to look at next? That's right, we want to look at our slope. Remember, what does slope have a verbal description of? Rise over run. Again, I see a negative sign, so I have to choose. Do I want to go down and to the right, or do I want to go up and to the left? Looking at where this first point for my y-intercept is, going up and to the left isn't even an option. We're going to have to go down and to the right. So this says we want to go down 2 and right 5. So from my y-intercept, I'm going to go down 1, 2, and to the right 1, 2, 3, 4, 5. Put another nice big fat dot, and if I eyeball that, sure enough, that line will have a negative slope. So I'm going to take my nice straight edge, line it up with my 2 points, draw a nice line, make sure I include arrowheads showing that this is a line which continues on forever. And I'm done.